Hello, RCHacker, Mark here. Now this is a follow-up to my last video. I forgot to mention and I forgot to test for GPS. Now BB Junkie made a comment on my last video and he said, yeah, what about the GPS frequencies? Very good question. You know, I did a lot of irrelevant testing in the last video. Mainly what we need to look at is our 433 and the GPS. If you've got any sort of return to home system or anything like that, very important that your GPS is getting a good signal. And if your camera is stuffing that up for you, then that system is totally useless. So I've set up the RF Explorer and she's scanning away now. I'll just turn the Mobius camera off that I had. And she's scanning away now. Now here on the bottom it says the center frequency is 1575.42. That's what I've set. That's the L1 GPS signal center frequency, and I've set the span as 35 megahertz. So that's 35 megahertz going right across here. So the GPS signal, it's a spread spectrum signal, but the bulk of it is in the middle here. So the bulk of it, of the GPS signal is what's on screen here. So we'll turn the Mobius on. This is just our background noise, and we'll turn our Mobius on. I've got it nice and close. There's one little spike came up there. Ooh, and there's another one, and I'll start it recording as well. And you can see the noise has actually picked up quite substantially there. Move it away, it goes down, bring it in. I do have to bring it very close for that noise to come up. And you should also note that I actually took off the attenuator as well. If I turn it around that way, the noise seems to be associated with the board itself. So it does put out a little bit of noise on the GPS frequency. We'll wrap it up in foil. I will ground it. I'll push the foil. It's worth noting that foil has this shiny side has a small layer of plastic to stop it, just to keep it shiny, I guess. And the other side, aluminium, gets a oxide layer which is non-conductive as well. But I'll push it up against the outer part of the USB there, just to see what happens. Just a very rough test. I'm not going to ground it. And yeah, that pretty much eliminates it from what we can tell here. Now let's test the old GoPro, if it'll turn on. There she goes. The GoPro, there's a little bit, if I point the actual lens at it, at the antenna there. But it's not so noticeable, it's not so bad as the Mobius. We'll also test quickly the Mobius on the extension lead, with the extension lead there. Let's put that lead right near it. Oh, there we go. With it right on it, touching it, it produces quite a lot, but as soon as you take it away, it goes down. So not quite as bad as that interference we were getting on the 433 megahertz there. But it is still there. Now, the important thing to note about the GPS signal is that the signal coming from the satellites way up in space is a lot weaker when it hits the our little GPS receivers, and those GPS receivers are designed to be very sensitive as well. So any small amount of noise that is produced by something like this may affect it more so than with our control systems. I'm not exactly sure what a GPS satellite puts out in power, but I think by the time it gets to the actual receiver, the signal there is quite weak. So keep that in mind, worth doing a bit of shielding and keeping that GPS receiver as well away from your, definitely the Mobius camera, even the GoPro camera. Anyway, cheers, thanks for watching. Apologies I missed this in the first video, but I'll link it all together and it should all be good. I'll catch you next time. Like I said on the front, I think it comes off. There we go. So that's our radio module.